This is Complex Numbers Part 2. In the first video, we learned that I is defined as the square root of -1. What I want to do right now is develop a chart that will show you what I to various powers will simplify to, like I squared, I cubed, I to the fourth, etc. So let's see if we can figure out what I squared is. Well, to make I become I squared, all I have to do is square this. But if I square the left side, I must also square the right side. And when you square something, that means you need to multiply that number times itself twice. So this is the square root of -1 times the square root of -1. Square root of -1 times the square root of -1 is just -1, because generally speaking, square root of x times the square root of x is just x. So that's what I squared is. It equals -1. This is an important fact to memorize. You will use this a lot. Well, let's see if we can figure out what I cubed is. To make I squared become I cubed, all I need to do is multiply by I. And if I multiply on the left side, I must multiply on the right side by I. The reason this gives me I cubed is because this is just using your exponent laws. I to the first times I squared. This is where we keep the base and add the exponents. So -1 times I is -I. That means I cubed is -I. That's another important fact to memorize. All right, let's go to I to the fourth. There's two ways to make I to the fourth. I could do something to I cubed, but there's an easier way to get an I to the fourth, and that is take I squared and square it, because that's the exponent law that says when you raise a power to a power, keep the base and multiply those exponents. So if I've squared the left side, I must square the right side. That means I to the fourth equals 1. So here's the chart written a little more neatly without all that other stuff written around it. You need to memorize this. I squared equals -1. I cubed equals -I to the fourth equals 1. A goofy little thing to think about is if you win some game, you're going to say, I won, I won. Just remember that it's the stuff in the middle that is your negatives. This is the chart up to the fourth power. Here's the chart going for 4 more. Notice this starts to repeat itself, and the reason it repeats is the same thing I just did. To make an I to the fourth become I to the fifth, let's multiply both sides by I. Well, 1 times I gives me I. To make this I to the fifth become I to the sixth, let's multiply by I times I to the fifth is I to the sixth. I times I is I squared, which we know from up here is -1. To get an I to the seventh, I'm going to multiply this by I. Multiply this side by I. -1 times I is -I. To get this to become I to the eighth, multiply times I. -I times I is -I squared. We know from up here that I squared is -1, so this is negative of -1, which becomes +1. So this whole idea can continue forever. Just keep multiplying by I and simplify. So this says that our powers of I repeat themselves every 4 numbers. So every higher power of I can be written as either I, -1, -I, or 1. Any power of I can be written as that. Because this chart repeats itself every 4 numbers, all we need to do to simplify a higher power of I is divide the exponent by 4. And then all that matters to us is the remainder. We don't care how many times 4 goes into the power. We want to look at the remainder. If the remainder is 0, that 0 becomes the new power on I, and we know I to the 0th is 1. You know anything to the 0th power is 1. If the remainder is 1, then that 1 becomes the new power on I to the first is just I. If the remainder is 2, that 2 becomes the new power, so this is I squared, and we know that equals -1. If the remainder is 3, then that 3 becomes the new power on I cubed according to the chart is -I. So it sounds complicated, but let's look at a couple examples and you'll be fine with this. To simplify I to the 21st, the first thing I'm going to do is divide 4 into 21. It is always dividing by 4 because the chart repeats itself every 4 numbers. This is plain old-fashioned grade school arithmetic. 4 goes into 21 5 times. 5 times 4 is 20. Subtract and get a remainder of 1. All that matters is the remainder. This doesn't matter. It's the remainder. That says I to the 21st is the same as I to the first. The remainder becomes the new exponent. and I to the first is just I. So really all of this just boils down to, if you can divide by 4, then you can do this. I to the 39th, I'm going to take 4 and divide it into 39. 4 goes into 39 9 times. 9 times 4 is 36. Remainder of 3. I don't care about that. What I care about is the remainder. So I to the 39th is more simply I to the third. And if you look at your chart from the other page, I to the third power is just negative I. I to the 72nd, I need to divide that by 4. 4 goes into 72. 4 goes into 7 once. Subtract and get a 3. Bring down 2. 4 into 32 is 8. 8 times 4 is 32. Subtract and get 0 as my remainder. Remember, this doesn't matter. What matters is the remainder of 0. So I to the 72nd is the same as I to the 0th, which is 1. So all you have to do to simplify any power on I is divide by 4, grab hold of the remainder, and that becomes your new power on I. And the only answers you are allowed to give are 1, -1, I, -I. Nothing else should be an answer for the simplification of I to the power. To multiply these, it's just using your exponent laws. 2i times 5i is just 10. I times I is I squared. And if this were a plain old variable, you'd be finished. But we know from the chart that I squared equals -1. So I can write this as 10 times -1, which gives me -10. But there's a quicker way to do this that doesn't require all this rewriting, and it's this. When you see I squared, what you want to do is cross that out and change this sign. This used to be 10. It needs to become -10. That's a lot easier than having to write out this product. So this, -5i times -7 is -35 I squared. And we know that we're going to take this I squared, cross it out, and change this sign so this becomes a +35. That's just easier than writing out this product. When we multiply these three, -2 times 6 times 4 is -48. That's just plain old arithmetic. But I times I times I, using your exponent law, is I to the third. I to the third is -I. So this equals -48 times -I. A negative times a negative is a positive, and 48 times I is 48i. And you could come up with a shortcut on that. I just hesitate to give you too many shortcuts. I like this one. I'd rather, for any other power, have you write it out. Multiplying this, a -3 times -2 times 4 is going to give me a +24, plain old arithmetic. But I times I times I times I, add all those exponents up, gives me I to the fourth. I to the fourth is just 1. So this is 24 times 1, which is 24. So I suppose we could do a little shortcut on that and just say when you see an I to the fourth, you can just cross it out. Don't write anything, just cross it out. Here's something you know from before. You know that the square root times the square root is just the square root of the product. So square root of 2 times the square root of 5 equals the square root of 10. But this is only true if the radicands are positive numbers. Then you may use this rule. If the radicand is a negative number, you must take the I out before you multiply, like this. This has got to bring an I out on both of those. I radical 6 times I radical 5. Multiplying the i's together gives you I squared. Radical 6 times radical 5 is 30. I squared, though, becomes a -1, and this is where we were just crossing that out and putting a negative in front. So this becomes negative times the square root of 30. 30 factor trees out, but there are no pairs, so that's as simplified as that goes. This next one, there's going to be some simplifying we can do at the end. Take your i's out. I times I is I squared times the square root of 12. But I squared can cross out and give me a negative, and the 12 can be factor treed out, and we get 2 radical 3. But it is a negative because that I squared supplied the negative. Like this, you cannot just do -6 times -2 and call this the square root of 12. Because that would give you a +2 radical 3 as your answer, and that's not correct. So be sure on these, with the products of the square root of negatives, that you take the I out first and then deal with it. Sometimes there's only one that has an I, and that's okay. So let's take the I out of this. Multiply gives us I times the square root of 48, which we can factor tree the 48. Here's our tree. We end up with 2 pair of 2's, which is going to give us a 4 radical 3, but it is 4i radical 3.